So let's start building the main screen. So back to Xcode, our main screen, we need to build the view first. So we'll add a start game button, and we're gonna call it start game. You can adjust its font size, color, anything that you would like, and then we'll add the different note buttons. So we'll go through all of them and make them the same concept, use the same file name here. Let's align them a little bit. And we need to add a label to display the answer. This is a label that will just say correct answer or incorrect answer. Don't need anything here. And this is the color, so I'll leave it as blank. And that's the label. Then the next step is to connect to the view controller. So the label need to be an outlet, so we can add that first here. So we call it label answer. Then the start game will need to initiate an event, so we connect it as an action. And we call it a start game. You can choose to use a sender, especially if you want to make changes to start game, or we'll say none here, so no actions coming with it. Then when the user click on if any of these, that will start another event as well. So we connect this here as another action, and we call it check answer. This one, we need to know which button was clicked, similar to what we did in the help screen. So we'll leave the argument as a sender and choose a UI button, since we know that all of them will be UI buttons. Then connect. I want to make sure that all the buttons are connected to that method, so I can drag from here to each one of the buttons, or I can click on the button and instead of adding a new one, I can connect to that function like that. So it says here connect action, so connect to the action. Now when you hover, all three of them are connected. So let's do that for all the different buttons. And maybe we should have connected one button and then copied the rest like we did with the help screen. But I also wanted to show you how you can connect a button after the fact to an existing function like we did here, or you can connect from the function to another component like we did before. So now make sure all of them are connected to that function, meaning that when the user makes the answer, it will work. In the terms of the model, there are few that I need to model over here. So the first one is the audio player. So this will need importing the AV foundation. Then I need to add the audio player. So I will say that variable player, and this will be AV audio player. And we'll use the exclamation mark, meaning that it doesn't have to be initialized. Then we need to do the same for the array, so I'm going to call it notes, or note URLs, since it's an array of the URL of the notes, and this will be NS array. and I'm also going to say I'll initialize this in the viewed load. Then we need the current note, so I'll say variable current note, and this will be a string, and also can be used without being initialized. Or you can initialize it by saying a string and say I just want any empty string, like that. So this is calling the initializer from the string to create an empty string and then assign that to this variable. If you do something like that, you don't really need to specify the type. Swift language can figure out the type by itself. So we got the note, and then I need the counter. So I'll say variable turn counter, and this will be an integer. And we also need the maximum, and it needs to be initialized, so I can initialize the counter to 0. And then finally we need the number of turns, so this can be a constant, so it's not gonna change, so I use let, and I'm gonna call it maximum turns. It is recommended to use capital letters for constants. This will be integer, and let's initialize it to 3. You can make this as many turns as you want. Just for simplicity here, I'm going to use 3 as the first one. Let's go back and see where we are. So we built the view, and we connected the components as outlet, and then in the viewed load to initialize the collection of the URL. This is very similar to what we did in the help screen, but instead of initializing one URL, we'll initialize all of them and put them in a collection. I already used the connection with the user interface, so probably I don't need that assistant editor anymore. And I'm working with the view controller, which is the controller of the main screen. So what we need to do here is to load the URLs of the different files, note files, to the note URLs array. So we as we did before, we need to first get the app bundle. So let app bundle equal ns bundle, and use the main bundle function to get a reference to the app bundle. Then we use the app bundle to retrieve all the URL. So I already created an NS array, so I don't need to do a let or a var anymore. The scope in which you define, see here when I say var within the scope of the class or let, this means that this object can be used in any of the functions within that scope. Whereas this one, the app bundle, since I use the let inside the scope of this function, I can only use the app bundle within that function. We call this the scope. Once you define an object, define it or create it, meaning that you use the var or the let keywords with it, you cannot use it again. You don't need to use it again. So for the note URLs, I'll just use the word note URLs and then say equal. Then I use the initializer of the NS array that I used before. No, not the initializer. I'll use the app bundle to get the URLs. See, there is one URL for resource, or there are URLs for resources with extensions. So, and if it is in a subdirectory, you can use subdirectory. In the case here, it is not in a subdirectory, it is in the app bundle. And that gives you any type. So we need to cast that as an array of the file. So what is the extension, which means it's going to go to the bundle, find all the files with that extension and load it. So we provide that extension as what we call a string literal, meaning a constant value of a string, in which subdirectory will say nil. Nil meaning that there is no value. So meaning there's no subdirectory. This method will grab all of this and put it in the array. And now we have our note URLs initialized. So this is done. Then in the start of the game, we need to reset the counter, then play the game. We observed that we need a play game function. So I'm going to come here after the check answer, which is the two functions that were created to connect to user events, and add another function of my own called the play game. The play game doesn't need to receive any arguments, and it will have a function body with the job to actually play the game. At the start of the game, I have the job of resetting the counter. Why do I need to reset it again? Because if the user keep playing multiple games, the counter will add every time a game is being played. So we don't need to do that. So we're gonna need to reset it in the beginning. The start game function is to start a game. The label will need to be reset as well as the counter. So maybe we can create a reset function as well. So we'll add another one called function reset game, and use this to reset the entire game. We know when the game starts and we need to reset, we'll reset counter equal 0. And then, so in the start game, we will call to reset the game. So we'll say reset game and call the function to play the game. So we'll say play game. So what is happening here, when the user click the start button, it will notify or come to the start game function to execute its instructions. There are two instructions in the start game. The first one is to go to the function called reset game, execute what's in here, and come back. The second, after it comes back, it goes to the function called the play game, execute what it has here, and then come back. And when it comes back, then the game will be over. It will wait. Actually, it's not going to be over. The function will be over, and it will be waiting for the user to take action, which in this case will be the action to check the answer of that the user clicked one of the other buttons. So this is the start game. Now in the play game, we need to play a random note if the counter is less than the maximum. So inside play game, now it's actually play game here is that it plays a single turn within the game, but it also manages the turns. So it manages all of them as well. So you have the turn counter. So before we play another turn, let's increment the turn counter. So we say turn counter equal whatever value it has plus another 1, plus 1. This means that now, because you're going to play a turn, so you increment it, indicating that we are now playing one more turn. And then check if this is more than the maximum number of turns. So if I say if turn counter is more than the maximum turns, if that is true, then play a random note. Else, which means if it is not true, end the game. End the game. So you see what's happening here. The user will start the game. It will reset the counter and call play game. Play game will come and will increment the counter. So if it is 0, now it is 1. You check, is 1 greater than 3? That is false. So it will come here. So we need to change that. So it should be the turn counter is less than the maximum turn, less or equal. So if the turn counter is less or equal the maximum turn, that is the true, because the first block that comes after the if statement is the one that will be executed if the condition is true. So we call that the true block. So this is where we want to play. We want to play the note if this is true, if the turn counter is less than or equal the maximum turns. So if it is 1, 1 less or equal 3, so it plays a note and then it will jump over the else, come to the end, then come here, and it will wait for the user to do the check answer. Then the check answer will need to call the play game again, and that will, when the user click on it, it will call play a game. So check answer will need to do multiple things. It will need to retrieve the text or the name of the note from the button. It needs to compare the note to the current note, and it needs to play a game again. All right. So let's go inside and do the random note. So to play a random note, we will need to get a random number between 0 and the number of notes. And we know that from the array because we can get the count of the array. We can use the same arc for random uniform function that we used in the first project, and there is another one called random. So we can say here let random index equal, and use a function called random, and the random function generates a number between 0 and 1. So if we need it between 0 and another number, we use a percent and then use the notes dot note URL need to have a space here, note URLs dot count. So that generates a random number between 0 and the number of nodes. This is called the modulus operator, or the remainder. It gives you back the remainder of a division, not the actual division, but a remainder of the division, which in this case will make the number between 0 and the random URLs. You can also use the arc for random that we used in module number 1 if you want. Then use the random number to retrieve a note URL. So I'll say here let note URL equal, and then go to the note URLs array and say give me object at index, and then use the random index as the index. And then this gives you the type of any object. So I'll say I need this as a URL. So that gives me the note URL. And then initialize the player. So I'll say player equal AV audio player, and use the content of URL function that we used before with the note URL, and then in the error will do nothing. And then finally play the note, not finally, we'll play the note. And then finally update the current note. So the current note is a string. The current note is a string that needs the last component of the URL path. So I'll say the current note equal, and then go to the note URL and say, can you give me your last path component? There is a function here called last path component. If you recall from the previous video, when we looked at when we put the breakpoint and looked at the structure of the URL starts with the keyword file : / then the entire path from the root to where the current directory is. The last component of that path is the file name, the full file name. So we'll say we want the last path component, and it returns an optional type. So we use the exclamation mark to say we want to do implicit binding in here. So that's what we do if for the random note at the play game. So that's this one. Then we go in the evaluation. If the user click on the check answer, then we need to retrieve the note from the button. So this is the sender, and we've done this before. So we'll say let label equal, and then it go to the sender and say give us the title label, and then we'll say let the user, and I'm gonna the text, and we'll say that this is the label dot text, and then let's compile the full note name so we can compare with the current note. So I'll say here that let user note equal the text, and I can add to the text the .mb3. The plus operator in Swift can do concatenation on the string. So I'm concatenating the content of text, which will be the A, B, C, D, with .mb3. So I use the string literal .mb3 so that the user note can take the same format as the current note. Now that I have them in the same format, I can then compare both of them. So I use another if statement for the comparison. So I'll say if the user note equal to the current note. If that is true, then we have correct answer. So I can go to the label answer and set its text to say correct answer. However, if this is not correct, it means it's a wrong answer. So I'll set this to be incorrect answer or wrong answer, whatever you would like to use. After we are done with this, then it's time to call the play game again. So I can use play game and call play game one more time. However, if I do this, there will be no time for the user to see the answer because play game will run the game directly. Now, I'll probably should wait and let you see that and not rush you. So let's go ahead and test. So I'm done with this part. So let's go ahead and test. So we'll run. So you started the game. We heard the sound. We clicked the answer. And you probably heard the sound. I got an incorrect answer, and you probably heard the sound. Two things happen here. That number one, the correct answer did not disappear. So I'm supposed to enter another answer, and I still see the incorrect answer. So I need somehow to, when I start another game before the sound is played, I need to reset that label to nothing so that I cannot see anything here. Then I notice once you click the button, you're hearing the sound. There's no opportunity for the user to see that what the answer was. It's probably we're done with the game now. So it is which was 0 became 1, then it became 2, then it became 3. And that will make the turns null and will end the game. So what we need to do is, instead of playing the game, we want to delay the second sound maybe for 2 seconds or 3 seconds. So when you click start game, and we probably in the start game we also need to reset that label as well. So when you click start game and you play game, but in the second time, in the second event, in the second event here, when this user evaluate calls play game, in this point, when it plays another game, it needs to have some delay. It needs a delay. Maybe 2 to 3 seconds delay before the second sound is played. So how can we implement this delay? It's not something that we discussed when we analyzed the problem, but when we did the testing, we realized that we need delay in the second sound. How can we implement a delay? There is a library called NSTimer that can allow you to schedule a function after a specific delay. So we'll go ahead and see how we can use that to implement the delay. The testing also revealed that we need to reset the label at the start of a game, at the start of a turn, and the game. So we probably need to add a function called reset, but at the turn level. We have a reset at the game level, but we need a reset at the turn level as well. And then we need to call that here in play game. So let's do them one by one. Let's do the easier first. So function reset turn. And in the reset turn, what I need to do is to reset the label answer. I need to reset the text to be nothing, empty. And when I reset the game, when the game is over and I click start another game, as I reset the counter, I also need to reset the turn. So I need to do both of them. Play game, before it plays the turn, it needs to reset the turn. So I'll call reset turn to reset the turn so I don't see that again. You see what we did? So we added the function and we called that from play game, and we also called it from reset game. Now to the play game. Instead of calling play game directly, we'll use the NSTimer. And the NSTimer has a function called scheduled timer with time intervals. The time interval is in seconds, and the target could be is what object are you going should respond to when. So the timer, the way it works is you say I want a timer every 1 second or after 2 seconds. So after 2 seconds, we call that the timer will fire. It's like alarm. So it will fire and go to the target, which is an object that you specify, and then go to a specific function inside that object. You can provide user info, which means any message that you want to send with the timer to the function, and then finally if you want to repeat that timer again or not. So we want to maybe give a 2-second delay, so we enter 2. Who is the target object? This, we want to call the play game function after 2 seconds. The play game is part of the current class on which the timer is being scheduled. So we use the keyword self to give us a reference to the current class. The selector is a string that represents the name of the function that you want to notify. So this is the function play game. If you want to send the message with the timer, in our case I don't want to send the message, so I'll use nil. And do you want to repeat the timer, or is it a one-time thing? In this case it's just a one-time thing, so I'll say false. So let's see if these changes will work for us or not. So we started the game, we heard the sound, we made it's an incorrect answer. Now you notice that the delay, so it waited a little bit, we looked at the answer, and then it's the sound displayed and the label disappeared and we heard another sound. So we click, and then that's the third sound. and we were incorrect in all of them, and now the game is over, so we did not hear any sounds. So we'll stop here, and in the next video we'll implement a dialogue to indicate that the game is over. We also want to maybe enhance the visual return that we are giving to the user at the end of the game. Maybe add a picture, or and add something, maybe color the text as well. So thank you.